In this video, I want to have a look at applications of APs and GPs, so that's arithmetic and geometric progressions or series. So on your formula sheet, you have all of these formulas. We haven't looked at this one yet, we'll look at that later in this topic, but all of these ones you did have a look at last year. So you need to be familiar with all of these formulas and know when to use them. Now, we're going to have a look in this video at applying some of these formulas to practical problems where we have to pull the information out, figure out whether it's an AP or a GP, and then go through and solve the problem that it's asked us. So our first example says that Sarah earns $42,000 in the first year of, that should be her new job, not his new job. Each year after that, she receives a $2,500 pay rise. We're asked how much she's going to earn in her 10th year, and then we're asked how much she's going to earn in total over those first 10 years. So the first thing we need to decide is whether it's arithmetic or geometric. So because it's increasing by the same amount each time, that means it is an AP that we're looking at. So then we can find our information. So our A is our first term, that would be our $42,000. Our D, which is the difference each time, would be our $2,500. And both our questions are referring to the 10th year or the first 10 years. So that means our N, our number of time periods, is going to be 10. So now we can go through and solve. So for A, we want to know how much she's earning in her 10th year, which means we want to find the 10th term. So to find the nth term of an arithmetic series, we're going to have the formula A plus N minus 1D. So in our case, we're going to have T10 equals 42,000 plus, well, 10 minus 1 is 9 times 2,500. And that will give us 64,500. So in her 10th year, she's going to earn $64,500. Part B asks us how much she will earn in total over her first 10 years. So this time we're looking at the sum. So we have two formulas for the sum of n terms of an arithmetic series. We've got n over 2 outside of 2a plus n minus 1d, or we have n over 2 outside of a plus l, where l is the last term that we're looking at. So in this case, we have enough information to use either of those formulas because we know that in the 10th year, she'll earn this much money. So we know what that L term is. So we could use either of these. I'm going to use this one because it's a little bit shorter and neater. So we're going to have 10 over 2 outside of our 42,000, which is our initial amount, plus our 64,500. And that's going to give us $532,500. So that's the total amount she's earning over those first 10 years. Our second question says that the population of a certain town is 10,000 people. Its population is going to decrease by 10% each year, and we're asked to find its population in 5 years' time. So in this one, because it's decreasing by a percentage each time, that means it is going to be a GP, a geometric progressional series. So our first term, our A, is our 10,000 people. Now our R is what we're multiplying by each time to get to our next term. So it has to do with this 10%, but our R isn't our 10%. If it's decreasing by 10% each time, then to find how many people there are in this town next year, we'd have to multiply it by 0.9 to find 90% of this population. So our R is 0.9 and our N in this case is going to be 5 because we want to know its population in 5 years' time. So our formula for this is to find the nth term, we're going to have A times R to the N minus 1. So in our case, that's going to be 10,000 times 0.9 to the power of 4, which will give us an answer of 5,904.9. But because we're talking about people, we'll write therefore 5,905 people in the town in that 5th year. So we're rounding to the nearest whole number because we're talking about people. So that's two examples of having a look at applications of APs and GPs to help you jog your memory.